गुड मॉर्निंग स्टूडेंट्स। मैं बिंदु डडवाल, लेक्चरर केमिस्ट्री, गवर्नमेंट सीनियर सेकेंडरी स्कूल कल्याड़ा से हर घर पाठशाला में आपका स्वागत करती हूँ। आज हम करेंगे केमिकल काइनेटिक्स से कुछ इम्पॉर्टेंट क्वेश्चंस। रेट कांस्टेंट डिपेंड्स ऑन टेम्परेचर, टाइम, इनिशियल कंसंट्रेशन, नन ऑफ दीज। टेम्परेचर चेंज होने से रेट कांस्टेंट की वैल्यू चेंज होती है। सो आंसर इज ऑप्शन ए, टेम्परेचर. The chemical reactions in which the reactants require high amount of activation energy are generally slow. The option A is the correct answer. क्योंकि सभी रिएक्टेंट्स को एनर्जी मिल नहीं पाती है, एक्टिवेशन एनर्जी, तो वो रिएक्ट नहीं कर पाते हैं, कुछ ही रिएक्ट करते हैं, इसलिए रिएक्शन स्लो होता है. If the concentrations are expressed in moles per liter and time in seconds, then the units of rate constant for the first order reaction are. For a first order reaction, rate is equal to K into concentration raised to power 1. So if concentration is in moles per liter and units of rates will be mole per liter per second, then units of K will be equal to mole per liter per second divided by, this comes to this side, so mole per liter, so this cancels and units are second inverse. So option C, second inverse, is the correct answer. Identify the order of reaction from the given rate constant K is equal to 2.6 into 10 raised to power minus 4 liter per mole per second. Order of reaction can be predicted from the units of rate constant. As in this case, the units are liter, mole inverse, second inverse, which are the units of a second order reaction. So we can say that the reaction is of second order. So option C is the correct answer. The units of rate constant for first order reaction is time inverse. Option A is the correct answer. Units of rate constant for a second order reaction is, for a second order reaction, rate is equal to K into concentration of reactant raised to power 2. Units for rate are mole per liter per second and unit for concentration is mole liter inverse raised to power 2. So K, units of K will be units of rate divided by units of mole per liter raised to power 2. So 1 mole per liter gets cancelled with this mole per liter and 1 is left. So liter on going to the top becomes liter raised to power 1. Mole becomes mole raised to power minus 1 and second inverse is already there. So units are liter, mole inverse, second inverse. Option C, mole inverse, liter, second inverse, is the correct answer. Role of catalyst is to change. कैटलिस्ट का रोल समझने के लिए इस ग्राफ को देखते हैं, विच इज़ बिटवीन एनर्जी एंड प्रोग्रेस ऑफ अ रिएक्शन. तो दिस इज़ द पाथवे फॉर अ रिएक्शन विच इज़ अनकैटलाइज्ड. बिना कैटलिस्ट के प्रेजेंस में रिएक्टेंट्स इतनी एनर्जी, एक्टिवेशन एनर्जी लेकर एक्टिवेटेड कॉम्प्लेक्स बनाते हैं और एक्टिवेटेड कॉम्प्लेक्स जो है प्रोडक्ट्स में कन्वर्ट होता है. तो ये रिएक्शन हो, इसके लिए इतनी एनर्जी चाहिए. लेकिन कैटलिस्ट जो है इसी रिएक्शन के लिए एक ऑल्टरनेट पाथवे प्रोवाइड करता है, जिसके लिए जो एक्टिवेशन एनर्जी रिक्वायर्ड है वो कम होती है. कैटलिस्ट रिएक्टेंट्स के साथ रिएक्ट करके कम्प्लेक्स बनाएगा और बाद में ये कम्प्लेक्स ब्रेक होगा, प्रोडक्ट्स बन जाएंगे ए बी और कैटलिस्ट अलग हो जाएगा. क्योंकि इस रिएक्शन में एनर्जी जो रिक्वायर्ड है वो अनकैटलाइज्ड रिएक्शन से कम है, इसलिए रिएक्शन फास्ट हो जाएगा. Because of lower activation energy of the reaction becomes fast. So the option is option C, Activation energy of reaction. Role of a catalyst is to change the activation energy of reaction. A reaction is found to be of second order with respect to concentration of carbon monoxide. If concentration of carbon monoxide is doubled, the rate of reaction will increase by a factor of 4. Let's see how this is done. So rate K into carbon monoxide square. If concentration of carbon monoxide is X, then rate 1 is equal to K into X square, and rate 2 will be K into, because the concentration of carbon monoxide is doubled, so it becomes 2x. So equation becomes 2x square. Dividing rate 2 by rate 1, we get rate 2 upon rate 1 is equal to K into 2x square upon K into x square. So rate 2 upon rate 1 is equal to 4x square upon x square. So rate 2 is equal to 4 times rate 1. So that means the rate increases by a factor of 4 times. So option B is the correct answer. For a chemical change, A changes to B, it is found that the rate of reaction doubles when the concentration is increased 4 times. The order of reaction is, to find out the order for this reaction, A changes to B. Let the rate equation be rate is equal to K into concentration of A raised to power. Let the order be X. So if first equation rate 1 is equal to K into A raised to power X, then rate 2, second rate, is 2 times rate 1 when the concentration of A is increased 4 times. So equation becomes rate 2 is equal to 2 rate 1 is equal to K into 4 into A raised to power X. Now dividing equation 2 with equation 1, we get rate 2 upon rate 1, which is also equal to 2 times rate 1 upon rate 1 is equal to K into 4 raised to power X into A raised to power X upon K into A raised to power X. So cancelling K, A raised to power X and rate 1 and rate 1, we get 2 raised to power 1 is equal to 4 raised to power X. Now 4 is also 2 raised to power 2. So we get 2 raised to power 1 is equal to 2 raised to power 2 the whole X. So as the base is same, the exponential equation becomes 1 is equal to 2 times x, or x is equal to 1 by 2. So the order of reaction is 1 by 2. So option D, half, is the correct answer. A first order reaction is 75% complete in 60 minutes. 50% of the reaction will be completed in integrated rate equation for a first order reaction is K is equal to 2.303 upon T log of A upon A minus X. As the reaction is 75% complete, so A is 100 and X is 75 and time given is 60 minutes. So K is equal to 2.303 upon 60 log of 100 upon 100 minus 75, which becomes equal to upon 60 log of 100 upon 25. This cancel out as 4. So K is equal to 2.303 upon 60 into log 4 is 2 square, so it becomes 2 log 2. So we get K is equal to 2.303 upon 60 into 2 log 2 is 0.3010. So 2 cancels out as 30, and we know that 2.303 into 0.3010 is 0.693. So K is 0.693 upon 30. Now we have to find out the time for 50% of the reaction to be completed, which is T half. So T half is 0.693 upon K, and K is 0.693 upon 30. So this cancels out, and T half is 30 minutes. So option E, 30 minutes, is the correct answer. Give differences between molecularity and order of reaction. Molecularity is the number of atoms, ions, or molecules colliding simultaneously with one another so as to result into a chemical reaction. कितने molecules एक साथ collide करके products बनाते हैं वो molecularity कहलाते हैं. Order of reaction is the sum of the exponents to which the concentration terms must be raised in the rate law equation. Molecularity is always a whole number. Order of reaction may be a whole number, zero, or even a fraction. Molecularity, in the concept of molecularity, is theoretical in nature. Order of reaction is an experimental value and cannot be determined from the stoichiometry of the equation. The overall molecularity of a complex reaction has no meaning. It is for simple elementary steps only. Order of a complex reaction is the order of the slowest step involved in it. In case of simple reactions, the molecularity is usually obtained from stoichiometry of the equation. Order of simple reaction may not be equal to the number of molecules of the reactants as observed in the balanced equation. Derive an expression for rate constant of a first order reaction. For reaction R changes to products, rate equation is rate is equal to change in concentration of reactant with dt. It is equal to K into concentration raised to power 1, as it is a first order reaction. This becomes minus dr upon R is equal to K dt. We bring minus to the other side, and so we get dr upon R is equal to minus K dt. On integrating the equation, we get integral of dr upon dt is equal to minus K into integral of dt. So on integration, we get ln R is equal to minus kt plus I, where I is the constant of integration. So to find out the value of I, let us consider at time t is equal to 0, the ln R becomes ln R naught, the initial concentration. So ln R naught is equal to minus K into time t 0 plus I. So I is ln R naught. Substituting the value of ln R naught or I in the equation 1, we get ln R is equal to minus KT plus ln R naught. So bringing KT to the other side and ln R to the opposite side, we get K equal to ln R naught minus ln R. As log A minus log B is equal to log A upon B, we get KT is equal to ln R naught upon R. Now to convert this natural log ln into log to the base 10, we will multiply it with 2.303. So we get KT is equal to 2.303 log to the base 10 R naught upon R. Taking t to the other side, we get K is equal to 2.303 upon t log R naught upon R. Now this is the equation for rate constant for a first order reaction. Find the following terms: half-life and order of reaction. So, half-life period of a chemical reaction is defined as the time during which the concentration of the reactant is reduced to half of its initial concentration. अगर इनिशियल रिएक्टेंट 10 ग्राम है तो उसको 5 ग्राम्स में कन्वर्ट होने के लिए जितना टाइम लगता है उसको हाफ लाइफ ऑफ द रिएक्शन कहेंगे. The order of reaction is defined as the sum of the exponents to which the terms must be raised in the rate equation to express the observed rate of reaction. For the rate equation, rate is equal to k into a raised to power 2 into b raised to power 1. Order of reaction is 2 plus 1 equal to 3. Give an example of zero order reaction. So H2 plus Cl2 in presence of sunlight gives 2HCl is an example of zero order reaction. Similarly, decomposition of ammonia at the surface of metals like gold, platinum, etc. is a zero order reaction. 2NH3 in presence of platinum and 1130 Kelvin gives N2 plus 3H2 is a zero order reaction. What is half-life period? Derive an expression for half-life period in case of first order reaction. We know that for the reaction, R changes to products. If it is a first order reaction, then the rate equation will be rate is equal to minus change in concentration of dr upon dt is equal to k into concentration of R raised to power 1. And if we find out the integrated rate equation for this reaction, we get k is equal to 2.303 upon T log to the base 10 concentration of R naught upon R. When T is equal to T half, that is the time taken for the reactant to be reduced to exactly half, then K will be equal to 2.303 upon T half log of concentration of R naught upon the R becomes half of R naught, so it becomes R naught upon 2. 2 comes upside, T half we take to this side, so we get T half is equal to 2.303 upon K log 2. But log 2 is 0.3010, so multiplied by 2.303 upon K will give you the half-life, as this multiplied by this is 0.693, so T half will be equal to 0.693 upon K. So this is the equation for half-life of a first order reaction. Define rate law. Rate law is a mathematical expression which represents the observed or the actual rate of a reaction in terms of the concentrations of the reacting species which influence the rate of a reaction. वो एक्सप्रेशन जो हमें एक्चुअल डिपेंडेंस ऑफ रेट ऑन द कंसंट्रेशन ऑफ स्पीशीज बताती है, उस एक्सप्रेशन को हम रेट लॉ एक्सप्रेशन कहते हैं. Explain the effect of temperature on rate of a reaction. The rate of a reaction increases with the rise of temperature. It has been found that in most of the cases, a rise of 10 Kelvin in temperature doubles and in some cases trebles the rate of a reaction. हमने देखा है कि ज़्यादातर रिएक्शंस में अगर रिएक्शन का टेम्परेचर 10 केल्विन बढ़ जाए तो जो रेट है वो कई बार डबल और कई बार 3 टाइम्स भी हो जाता है देन द रेट ऑफ रिएक्शन. ऐसा इसलिए होता है कि जो मॉलिक्यूल्स हैं उनकी एक्टिवेशन एनर्जी जो है वो बढ़ जाती है, और जो नंबर ऑफ मॉलिक्यूल्स जिनकी एक्टिवेशन एनर्जी थ्रेशोल्ड एनर्जी से ज़्यादा है वो डबल या ट्रिपल हो जाते हैं, इसलिए रेट ऑफ रिएक्शन डबल या 3 टाइम्स हो जाता है। What are pseudo-unimolecular reactions? A reaction with molecularity 2 but order of reaction as 1 is known as pseudo-unimolecular reaction. In these reactions, the concentration of one of the reactants is so large that it does not put any effect on the rate of reaction, and so the order is reduced to 1. For example, hydrolysis of ethyl acetate is a pseudo-unimolecular reaction as it depends only on the concentration of ethyl acetate and not on the concentration of water. Give an example of reactions of first order. 2N2O5 gives 4NO2 plus O2 and H2O2 gives H2O plus half O2 are examples of reactions of first order. Give examples of reactions of second order. 2NO2 plus F2 gives 2NO2F, ये second order reaction है. इसी तरह 2HI gives H2 plus I2, ये भी एक second order reaction है. Give examples of reaction of third order. 2NO plus Cl2 gives 2NOCl, third order reaction है. 2NO plus O2 gives 2NO2, ये भी एक third order reaction है. Give examples of reactions with fractional order. CH3CHO at 723 Kelvin gives CH4 plus CO. Order of reaction is 1.5. CHCl3 plus Cl2 gives CCl4 plus HCl. Order of reaction is 1.5. These are fractional orders of reaction. So in this video, the things that we should remember, the things that we have done so far are how to find units of rate constants of different order of reactions, how to derive expression for rate constant of a first order reaction, how to derive expression for half-life period of a first order reaction, and how to solve different numericals based on first order reaction. We also learned examples of zero order reaction, first order reaction, second order reaction, third order reaction, and order of reactions with fractional order. In our next video, we will practice some more multiple choice questions, true and false questions, some numericals, some more differences, derivation of rate constant for a zero order reaction, derivation of expression for time period for a zero order reaction. Practice the worksheet given along, and also some numericals on the chemical kinetics chapter. That is all in today's video. Keep practicing, keep learning. Thank you and have a nice day.